Index page, what it was happen here, topic number, topic, and okay, page number. So the clear information was located in the index page. So here you have a topics, and each topic is located in which page number. The page number also clearly they mention. Okay, now. So when it was having like this, then advantage of user, what it is now. Suppose you want to take any one particular topic, for example, the topic is joints. If I want it, then what this user will do, first this user will go to index page, because index page is there now. So he will go to index page. So in index page, what it was happening, okay, what it was happening here. So it will be going to taking out, okay, na? So each index page, whatever it was there in index page and what are the topic and page numbers are there. So he will be searching only index page. Suppose in the index page, your joints is located in the 45 page number. If I knows that my topic is located in which page number, then based on that page number, okay, this user directly go to that page 45. Okay, na? It will be take a 45. Understand, na? So that means what happened here, my searching time will be reduces. I don't want to need to search page number 1, page number 2, page number 3. I don't want to search like this. So directly my required topic is located in which page number. That number, if I know it, then I can directly jump on that page without searching any pages. Yes or no? In that cases, what it was happening here, your searching time will be reduced. When searching time is reduces, automatically your retrieving topic is very fast. And whatever the performance of database is also very fast. Okay, na? So this is what the advantages of your index page. Got it my point now? Advantages of your index page. Okay. So how the index pages are working in your textbooks, in your books or textbooks, same as now you just go to think about here. Okay, now you just go to think about here. Now I have a table. This is a table. In table, we have so many rows. Like here, 500 rows we have it here. Okay, 500 rows we have it here. So now what we want to do, suppose this user wanted 45 or 45th row, he wanted here. 45th row, he wanted here. So 45th row he wanted means what you want to do, suppose first this user will go to checking here on this table, is there any index pages there or not, that checking. Suppose there is a no indexes on this table. If there is a no index, then what server will do as per user request, your Oracle server will go to search each and every row is going to be searching. Each and every row is going to be searching. Okay, now? So definitely it was going to be taking much time to retrieving my specific row data from this table. Understand now? So now that is going to be happen. So instead of searching your entire the table, okay, what the people will do in database side, they will be created a indexer, they will be created. They will created one index object is created. When we created index on a table, then user, whenever he wanted specific row, based on this indexes, your Oracle server will go to directly 45 page or 45 row, and immediately it was picked from your table. So your searching time will be, okay, reduces. And quickly we can access our required data. And also performance wise also it's very good performance will give it us. Okay, now? So these are advantages of indexes. Okay, so simply how the textbooks we have indexes, how it was working to, okay, to us. Okay, same as your database indexes also like that. So that means what I'm saying here. So it is a database object. Okay, now? So which is used to retrieve or retrieving a specific row, a specific row from a table fast or quickly. So this is index objects and index advantage. Okay, right. So here almost every databases, okay, now almost every databases is going to be supporting the two types of searching mechanisms on your table data. That means whenever user want to retrieving some row or some data from your table, internally there are two kind of searching operations will be performed. And what are those? And almost every relational databases will supporting these two types of searching mechanisms. Okay, now that mechanisms are, so all databases are supporting, all databases are supporting two types of searching mechanisms. Okay, so those are, first one we called as here table scan mechanism is a one thing. Second one we called as here index scan mechanism is another thing. Okay, now your table scan we called as here, this is a default mechanism, guys. Suppose are you not created indexes on a table, okay, then automatically your Oracle database server will be followed here table scan mechanism. Okay, now when it is not going to be created indexes, then automatically it will be following table scan mechanism here. Okay, so now, and if you created index, okay, how it was searching? If you are not created index, how table scan will be searched? So the two methods I will show you, and let me check it out which method will be faster to quickly or to fastly accessing your specific row data. Okay, now the first we will discuss about, guys, table scan. So this is default scanning mechanism in our database here. It is a default mechanism here. Okay, so in this mechanism what it was happening, sir, means that in this mechanism or in this scan, your Oracle server is going to be search each and every row in your table. So your table is having 10 rows, 5 rows, 5 lakhs, 2 lakhs, is none of the matter. But how many number of rows we have in the table, that entire the table will be check or search. Okay, now? So what I'm saying here, in this scan, Oracle server is searching, okay, the entire table. The entire table will be searching here. Okay, now? Now how it is. For example, we are sending one query request. What is my request? Select a star from so-and-so table where salary is equals to 3,000 rupees. I'm sending now. So this is my query request. So as per this request, what it was happening, guys, here, this request will go to database server, and database server, as per this request, it will go to table first of all. And which table here? EMP table. It will go to first EMP table. So first server will be checking on this EMP table, is there any index object is created or not? It will be checked. If it is not created, then by default, which scan is performed? Table scan is performed by default. When index object is not created. Okay. So tables can automatically perform by default. If index scan is created, then the first priority the server will give to you indexes only. Because of quickly accessing purpose, it will give first priority index when we created. So these are the two techniques. Okay, sir. So suppose index scan I'm not following here. I'm sending my query to my Oracle server, and Oracle server will take this request. As per this request, it will go to table and checking is there any index are there or not there. If it is not there, then following table scan. Okay, now how it will be following, let me see. We will go to see practically. So as usual, need to connect. Okay, and this is my table information, and carefully check it out. This is our table. Okay, and now this table, I'm going to take my previous or the initial table I'm taking, whatever the data was there in this. So already you know now, this Oracle demo tables already you have it now. So now here I'm going to inserting some data now. This is original information about your table. So finally I just committed. After committed, let me come out and see your table EMP. So this is my original table and data was there. Okay. So what I'm doing here, I'm writing some condition. Okay, some request I'm writing. Select a star from EMP where sal is equals to 3,000 rupees. So here carefully observe. Here which column is my conditional column means the salary column. So I'm going to retrieving the data based on salary column. Okay, now based on salary column, I'm retrieving. But before you need to perform, before you need to retrieve the information from this table, okay, what I'm saying here, this request will go to this complete query request will go to Oracle server. Oracle server will come to this table, EMP table. In EMP table, which column basis are you retrieving data, guys? Come on. On which column basis are you retrieving data? Yes, it is the salary column. Then this Oracle server will come to salary column. On this salary column, is there any index is created or not? Checking first of all. On this salary column, is there any indexes are created or not? It will be checking first of all. Understand now? So now how it will be checking, sir, and how I knows on this column, okay, you have a index object or not, how the user or how the server will knows that. How the server will knows that means there is one data dictionary, we have it here. And by seeing of the data dictionary, I can find out whether on this column index object is created or not. Okay, let me go. Now I'm going to, before to this, okay, I want to check my desk user underscore ind underscore columns. It's one of the data dictionary. So in this data dictionary, one of index name is there and column name also there and table name. Okay. Then I want to call. So select column underscore name, index underscore name, table underscore name from user underscore ind underscore columns, and where table underscore name is equals to EMP. Now see, now it was showing what now no rows are selected. That means now on this EMP table, on any of the column, do you have any index, guys? Do you have any index on this table? Yes, we don't have it here. So there is a no indexes on this table. Clear now? There is no indexes on this table. So now there is a no index that's confirmed. We confirmed here. And now user sending the request where salary is equals to 3,000. So whenever they was sending this request, what it was I'm saying here, if there is no indexes on this column or on this table, then what happened? Your Oracle server will go to checking each and every row value. Okay, now? So my condition here, what now? My condition is salary is equals to 3000 is my condition. As per this condition, it was checking each and every row. Now 800. So condition is false. Next is 1600. Condition false. Next is 1250. Condition false. Next is 2975. Condition false. Next is 1250. Condition false. Next is 2850. Condition false. Next is 2450. Condition false. Next 3000. Condition is true. So you're careful observe. Once the condition is true and your required value was found in particular area, so your Oracle server searching will not stop here. Understand my point now? Oracle server is not stopping your searching mechanism. Okay. So still it will be continued. Okay. Next it was continue with the 5000. Condition false. 1500. Condition false. 1100. Condition false. 950. Condition false. Next 3000. Condition true. So that means here how many rows we are fetching from this table, guys? As per our given condition, how many rows will come to me? Come on, guys. Yes, there are 2 rows will come to us. There are 2 rows are come to us and 3000, 3000, 2 rows are come to us. Okay. Now the point is what now? This request when I'm sending here, when there is no indexes, as per this request, your Oracle server comparing, how many rows are comparing, guys? Yes, 14 rows comparing. How many rows? 14 rows comparing. So now just logically calculate. For each row, it will take 1 second of time. Then total 14 rows comparing purpose, it will take 14 seconds of time. So 14 values comparing purpose, it will take 14 seconds of time. So that means finally the conclusion of this, what it was telling us, to retrieving data from your EMP table, whose salary is 3000 for the data retrieval purpose, your Oracle server is taking how much time it was taking, guys? Come on. How much time your Oracle server is taking to retrieving your data from your table? Yes, there are 14 seconds it was taken. Okay, na? So what I'm saying here, just assume, I'm telling assume here, not exactly I'm telling. What I'm telling logically, what I'm thinking, if each row comparison purpose, if your server will take 1 second of time, for logically I'm telling, then what happened? 14 rows is equals to 14 seconds. If you assume like this. Okay. So that means I remember, I just go to keep it this, and time is 14 seconds. So now the situation is what now? Now the situation is what now? Is there any method is there, the same data from the same table to retrieve, which was happening less than 14 seconds? Got it my point now? Is there any technique is there? The technique will be useful to me to retrieving the same data from same table less than 14 seconds. Okay, that I want to check. And now tell me guys here, If you have a technique less than 14 seconds time, if I'm retrieving the same data from the same table, then which will be preferred? 14 seconds method will be preferred, or less than 14 seconds method will be preferred? Which you prefer, guys? Come on. Okay, so definitely. So we want to go for less than 14 seconds. Let me see. Now, this is a table scan I was explaining to you. This is what it was happening. So now let me go for index scan, how it was working index scan. Come to index scan. First of all, in this mechanism, what it was happening means, first, once you created your index object on any particular column of a table, okay, your server, your Oracle server, as per user request, it will go to checking on that column, are you created any index or not? First checking. If it is created, then it will be comparing or checking only index page level only. It will be checked or it will be scanned, not other columns, not other rows. Only index column. On which column are you created index? Based on that column, it will be created internally one index page. Based on that index page, it will be scan your required data. That's how it is observed. So what I'm saying here, in this scan, Oracle server is scanning based on indexed column, wise. Okay, na? Based on indexed column wise, it will be search. Now, in this index scan, are these index objects, how we can create it means, okay, here, index objects are created in two ways. Okay, first one is called as the implicit indexes. Second one is called as a explicit indexes. The index objects are two ways we can create. Implicitly we can create, or else explicitly we can create. Now tell me, what is the mean by implicit? Come on, guys. What is the meaning of implicit and explicit? Yes, implicit is nothing but system defined. That means system automatically created. That is the mean by implicit. Explicit is nothing but user defined. Okay, na? User creation. So that means here I will say implicit means we called as a automatic. Automatically. Automatically means what now? System. So explicit is nothing but manually. Manual is nothing but user defined. Okay, now? Right. So now let me see. First, I will show you implicit indexes. Okay, how the system is created index objects automatically on your table columns. Okay, first I will say. So implicit indexes are when it was created by system means when we created a table, careful observe, when we created a table with the unique or primary key constraints, with unique or primary key constraint, create a table with unique or primary key constraint, then internally, okay, system is created an index object on a column automatically. Okay, na? So when we created a table with unique or primary key constraint, then internally system is created an index object on a column automatically. Okay, na? This is what the implicit indexes we called. Let me see. I'm showing practically also. Okay, let me come back. Some any existing tables are there. I'm dropping here. Test number 1. Test number 2 also. Okay, fine. Okay, carefully observe. Now I want to create table test 1, serial number enter. On this, I will apply unique constant, for example, and some name I'm giving varchar to offer some size. So now carefully observe, you applied unique constraint. That means, are you created your table along with the unique constraint? Are you created? So whenever we create a table with unique constraint and then see your index is created or not, internally check. But how I can check index is created or not means the same data dictionary. The previously we called now, yes, user underscore index underscore columns. So with the help of this data dictionary, I can see column name, on which column you created index object, what is your index name, and on which table you created. Okay, now from okay, so and so data dictionary where I want to say table name is equals to test number 1. Now you can see column name, serial number, index name, sys underscore c 0077557751, and table name test 1. Now see here. Now your index is created by system automatically or not? Come on. Okay, right. So now what has happened? Index successfully created. Okay, so my index name is sys_sys means system defined. Some number, serial number, and test. Okay, right. So now in the same pattern, one more table I'm creating, test number 2. So employee ID. So there I'm using primary key. Suppose employee name. And here primary key through I created here. After that, again, you can see your index is created or not. Then you can see your data dictionary test number 2 and execute. So again, here also on EID column, your index is created, the table number test number 2. So that means finally what you understand, guys, here, when we created a table with unique or primary key constraints, internally your systems are, or your system is going to be created index objects. Okay, now, so that is practically we proved this. So now I just take it out this. This is what implicit indexes we called. What we call this is implicit indexes we called. And one more example. Implicit indexes we called. Okay, that is what. Now the next one is called as what now? Explicit indexes. Now I want to go for explicit indexes. So explicit indexes means, okay, which was created by user. So manually, he will be created index objects on his required columns in a table. But here observe, the user, how he can create it and how many ways he will be created indexes on table columns. Means that, here observe. So these indexes are created by user in different ways or different types. User in different types of indexes or index objects. Okay, na? So these indexes are created by user in different types of index. Okay, na? So you have two types here. First one we called as, guys, here B-tree index is the first type. B-tree indexes. And second one we called as here bitmap index. So these are two types of indexes can be created by user. One is we called as a B-tree. One is we called as a bitmap index. So B-tree bitmap indexes are how internally preparing and how it will be working here also. The first I will interacting with your B-tree indexes. So B-tree indexes, again, there are some types. Again, they have some types. In this first one is called as a simple index. Second one we called as a composite index. Third one is called as a unique index. Fourth one is called as a functional based index. So that means your explicit indexes are, again, they have 4 types: simple, composite, unique, and functional based indexes. Okay. Now let me see the one by one index, how it was going to be work. Okay, now the first we will discuss about the simple indexes. First we will discuss. So what does the mean by simple index and how these indexes are created and how it will be work? Okay. So when I call index is a simple index means when we created an index object on index object based on a single column. So only one column wise my index object is created, and that column may be anything. So any type of column, but only single column should be used. Okay, now? So these kind of indexes are called as simple indexes. We called one column wise. We are creating our index. Then see what is the syntax of creating simple indexes. Index name on table name of, give it your column name. Got to my point now? I will go to example. So previously in table scan mechanism, okay, so this is our requirement, yes or no? Select a start from EMP where salary is equals to 3,000 rupees. So this particular rows data, if I want to retrieve from the table, your Oracle server is comparing 14 rows. And what we assume, one row is equals to 1 second. That means 14 seconds of time was taken. This is where in table scan. Now, this is when it was happening without index, when we follow table scan. Okay, but now the same requirement I'm going to using here to retrieving the same information from the table. Okay, but after creation of indexes. Okay, what it was happening, you can see. The first I have to go to create my index first of all. Okay, let me come out and see. Create index I1, index 1 on the table of EMP of which column? Salary column. So first I'm creating index here. After create index, what it was happen, now you can see your table. Okay, your data dictionary, you can see EMP table. Tell me guys, do you have index now? Are you successfully created index or not? Come on. Yes. So we successfully created index on column of salary, I1 and table. That's okay. But once you created index on particular column, and after that, I'm going to sending my query request, select star from EMP, okay, where salary is equals to 3,000. The same query, same condition. When I'm executing now, the same output will come. But this output, within how many seconds, okay, your server is going to be retrieval this data. Previously in table scan, it was a 14 seconds. But now here, how many seconds? And internally, B-tree indexes are how it is working. Okay, na? Internally, B-tree indexes how it was working means you're careful observe. So as per your request, what it will do guys here, as per your query request, and what is the conditional value? Salary is equals to 3,000. So based on this request and this conditional value, your salary column data, how many columns are, how many values are there in the salary column? How many values are there in the salary column? Each and every value will be arranging in B-tree format. Internally, it was arranging what? B-tree format data arranged here, not in tabular format. Okay, not in tabular format. It was arranging your data in a B-tree format. So B-tree format, how it was arranging, sir. Okay, now we can see. Let me come out and I'm creating this index here. So successfully index is created. After that, I'm giving some request. After index is created, I'm sending this. And careful observe, very easy. So B-tree indexes, immediately it was creating B-tree index. So B-tree index, okay, is created now. And here tree means what now? Having some levels. How the data will be storing in tree format. Tree format means what now? Levels are there, like a root level, parent level, child level, like roots are there. Some levels are we have. So root level started, but root level from where it was started means your root level started from the given condition. What is the condition I was given here? That is my root value. So salary is equals to 3000 is my root value. Which conditional value are you given? That is your root value. Okay, now? So now I'm keeping the root value left and right sides. Careful observe. The root value left pointer LP. LP means left side pointers. Left side pointers, that means left side of root value, less than values are storing. Careful observe. So which value is less than to 3000? Those less than values are saved or storing, okay, or keeping at the left side direction. And which value is greater than or equals to 3000? Those values are keeping under right side pointer here, RP. So your left means LP means left side pointer, R means right side pointers. Okay, and this is what I'm saying here. It's called as a root level. This is called a root level. The tree will be started now. The tree will be started now. Okay, right. So now under root, now you can see under root, now I will create a parents now. How the data will arrange it, sir? Here means the data will arrange it here. Careful observe as per your column. Which column? Salary column. And now come back. In salary column, so much and so many informations are there. So many values are there. In this all values, which is the biggest value, guys? In salary column, what is the biggest value? 500. So 500 is the biggest value. We'll take and compare with this 3000. Now tell me, 500 when you comparing with the 3000, which side it will be stored? Left side or right side? Right side. Then right side it will be keeping. So 5000 is in the parent level. So here also same. The 5000 less than values will keep into left pointer LP. Greater than or equals to will keep into RP. Will keep into right side. And this is what we called as, guys, here. This is called a parent level. This is called a parent level. Okay, I just keep it this. Next, what is the next biggest value, guys? $3,000. So 3000 row, how many rows are there? 3000 in my table. 2 rows are there. But can you remember, guys, here in my table, each and every row is having a row ID number, na? Yes or no? Row IDs we discuss, huh? Yes. So row IDs are there. Now let me come. So now 3000 compare with 3000. Which side it will come? Right side. Right side already 5000 is there. Compare with 5000. Which side? left side. So that means here left side will be same. 3000. But 3000 value or rows, how many rows in my table? 2 rows. Then I'm keeping here 2 asterisk symbols. Sir, this is called as a child level. And here asterisk symbols is nothing but what, sir? Means that your asterisk is nothing but representing row ID. So your row ID is nothing but, simply you remember, a row ID is nothing but it is a page number in textbook. Row ID is nothing but what now? Page numbers in textbook. So this is the arrangement of data. Same as next. What is the next biggest value? After 3000, what is the next biggest value? 2975. 2975 compare with the root value. Left side or right side? Left side. Okay. Same as less than. Okay. If it is LP side, then 2975 will take and right pointer, it will take greater than or equals to. Greater than or equals to. Okay. This is right side. Now next, after 2975, what is the next biggest value? 2850. 2850, how many times it was? 1 time. And now compare with the 3000, which side? Compare with the 2975, which side? Left side. So left side will be saving here. Left side. Okay, next it will come to left side. Left side what now? 2850. Is a 1 asterisk. That means page number 1 only. The page number only 1 page. Your page number is showing star because 1 time it was repeated. Okay, comma. What is the next biggest value after this? 2450. How many times it was? 1 time. Come to compare with the 3000, which side? Compare to 2975, which side? Left side. So you're saving. What is that? 2450 is I'm giving 1 asterisk symbol. Okay, next. What is the next biggest value after 2450? $1600. How many times? 1600? 1 time. So now you can come out 1600 also saved here. It is also 1 time. Okay, right. Comma. What is the next biggest value after 1600? 1300. How many times 1300? Sorry, 1500 is there, na? Sorry, 1500. How many times 1500? So 1500 also left side it will be stored. 1500 asterisk symbol, comma. What is the next biggest value 1500 after? 1300. 1300, how many times it was there in the table? 1 time. So now 1300. 1300, 1 asterisk. Next, after 1300, what is the next biggest number? 1250, how many times is there? 2 times. So 1250. First asterisk symbol, comma, second asterisk symbol. Okay, right. After that, next, what is the biggest number? 1100. 1100 also coming to left side now. 1 asterisk symbol. Next, what is the biggest number next? 950. 950 after 800. So these are the final biggest. So 950. It is also only 1 asterisk. Next one is 800. It is also 1 asterisk. So this is the arrangement of a binary tree. B tree stands for binary tree. So root, parent, child levels. And every asterisk number or asterisk symbol is representing row ID. And row IDs are permanent, already we know. And your row ID is nothing but you just assume it is a page number in book. In textbook, how we are taking page numbers. So your row IDs are working like a page number. Okay. After data arrangement like this, then what it was happening, you can see. Then this request, as per this request, Oracle server will go to B tree index. B tree index here, okay, the first level root, parent, child level. So first root level is comparing this conditional value, comparing with the first root level. This is first comparison. So 3000 equals to 3000. That means here which will come as per this right side will come here. In the right side, 3000 comparing with the 5000. This is second comparison. Then 3000 less than 5000, then it will come to left side. And left side is comparing 3000 is equals to 3000. So condition true. Condition true means as per your asterisk symbol, it was a directly jump to that page number. Okay, now? And pick the data. Next to one more page number is there. Based on that page number, directly jump to that page number. Second row is pick. That means this is third level comparison. Okay, now? So that means what happening here? I have a 14 rows. But as per your binary tree indexer, directly jump to this row. Directly pick this row. Next, directly pick this row. So that means the first rows, these rows are not searching on the table. These rows are not searching on the table. This row is not searching on the table. That means how many rows are not searching? Carefully observe. How many rows are not searching? 1, 2, 3, 4, 5, 6, 7. 7 rows are not checking. Next, 8, 9, 10, 11, and this is 12. That means 12 rows, your database server is not searching. That means 12 rows means how many seconds time will be saved? How many seconds of time will be saved? Come on. 12 seconds of time will be saved. Understand my point now? 12 seconds of time will be saved. That means your data, whatever I'm retrieving this data, Oracle server retrieving with how many seconds? With how many seconds this data retrieving? That is what we call as a, here it will take 2 seconds of time. 2 seconds of time. But table scan is going to be checking 14 seconds of time. Now tell me, which one is better? Come on. Which one is better? Index scanner, table scanner? Here index scan is better. So this is what we called as a indexes advantage, time saving method. Searching time will be reduces. Okay, na? Performance will be improved. Quickly accessing your required raw data from a table. Understanding now? So these are indexes, and especially B-tree indexes will be working internally while you are retrieving data from a table with the help of a index concept. Got it now? This is what we called as a index and table scan differences. So table scan, what we said, entire the table will be searched. But you are not searching entire table based on your B-tree index page. It will go to index and taking your necessary data where it is directly go to that row and pick from your table. That means in your table, the remaining rows, whatever it was there, those remaining rows are not searching by Oracle server. Suppose your table is having a 1 lakh rows out there. Then in 1 lakh rows, okay, so 9,900 or 99,098 rows are not searching. Only within 2 rows, as per your binary tree index information, directly 2 rows are picked. That means within 2 seconds only your data will pick up. Okay, na? So this is what we called as, guys, here indexes advantage. Okay, so this is a simple indexes, how it was working, and how binary tree indexes will be arranging your data, and later how to using this binary index by Oracle to retrieving purpose. Okay, na? Right, guys. So now I stop it here, and tomorrow we will go for the remaining types of